Most people here are pretty new to Kubernetes?
Yeah.
All right, great. I guess I have the right context set up. So we're going to split the time. We're going to do a small introduction to Kubernetes. And then we're going to jump into Q&A. I'm expecting you to ask really hard questions. It took me 30 hours to get here. Okay? So I'm hoping there's going to be really, really, really good questions. The first thing you should know is I'm very opinionated about Kubernetes. I doubt most developers should ever use it directly. Kubernetes is not for developers, in my opinion. It's for platform teams to build a platform so the developers don't have to think about this stuff. So when we're looking at this presentation today, I am not one of those people that believe everyone needs to be using Kubernetes directly. Indirectly, yes, but not directly, and hopefully I'm going to be able to show you why. Anyone knows what this picture is from? What movie? Yeah, there's black women in the space program, and it's called Hidden Figures. Okay? So the point of this particular slide is I like to tell this story about what technology is and what it's supposed to do for people. So for me, my introduction to technology is from my mom, actually. So most people tell you, hey, they've been writing programs since they were 4 years old. Not me. I didn't have my first computer until 11th grade in high school. Okay? So technology to me is more of a tool to achieve some goal, but I don't typically get too excited about the underlying technology. So when I was maybe 8 or 9, my exposure to technology is to figure out how to better your life. So my mom was a seamstress, kind of working in some factory making clothes. You don't make very much money, okay? So I have a single mom, and she wants to improve her life. And one way of doing this is she wanted to get a job working for US Customs. So in the US Customs Border Patrol, but you have to learn how to type. So she goes to the job interview, and they're asking, how many words can you type per minute? And she was like, what's fast? So she goes home, and she buys a typewriter. Anyone remember what a typewriter is? There are some people who've never seen one. They look like it. They have a keyboard attached to them. And I remember she was teaching herself how to touch type. So she buys a little book. So this is before you have software. You buy a little book, and you flip, and it teaches you how to touch type. And when you're young, all you can hear is, some people still type this way. You know some people that type with one finger? Do you hate pair programming with the people who type with one finger? It's like, let me type for you. So my mom was teaching herself how to type this way. So as a young kid, when you're sleeping or you can kind of hear your mom practicing, the typing gets faster. It goes from tap, tap, tap to tap, 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 tap. But you're too young to understand what's going on. So she comes home from work one day, and she has a new uniform on. She has a real job now. She has a job with healthcare benefits, off on the weekends, home at nighttime. Why? Because she learned how to touch type. She did not go to a conference for typewriters. This was not digital transformation. This was not DevOps. She was just learning how to type to do the ultimate mission, which was to get the job. When I see most of this new technology, people go crazy. Oh, Kubernetes conference. I'm a Kubernetes administrator. I'm doing digital transformation. And then you waste a bunch of time doing Kubernetes things, but it's really not that important. The things you do above Kubernetes are super important. So most companies and people will spend a bunch of time working at this low level. The other bad part is they're going to make all their developers work at this level. And it's really unfortunate because this is not the actual goal. So I'm going to walk you through the rest of the narrative. Okay, so this movie, Hidden Figures, in this particular scene, they're trying to get a man to space and back again. Okay? So this is a new problem at this time. Getting someone to space and back again. And they don't know how to do it, and they need to try to discover the math to make this work. And everyone is throwing out new ideas, new suggestions, because this is obviously a new problem. So someone in the audience is like, hey, I've seen this before. And then they suggested a problem or a solution from 40 years prior. And they run, they go find the old book. They look at the solution, and it turns out the old algorithm, the simple algorithm, solves the new problem of how to solve this particular trajectory problem to get back. Everyone is wasting time, millions of dollars. All these people are doing DevOps. here. This guy's using Terraform for no reason. Everyone is over-optimizing because they didn't really understand the actual problem. So in this concept, Kubernetes is very similar. I'm warning you because I'm going to save you 8 months to 1 year as you adopt Kubernetes if you pay attention. This is my favorite character in Hidden Figures. She's depicted as Dorothy Vaughan. So she's one of these people that are running the human computer department. So these are, women used to dominate IT at a certain time.
Yeah, because it was very low pay.
Very low paying, and also they just had the skills. They were the mathematicians. Some of the best mathematicians were doing all the calculation work. So they had the discipline, they had the skills, and these were the human computers, and in the movie, this is their leader. So in a room like this, it would be predominantly women, and we'll see 2 or 3 males in here. And that was the time frame. Now, she was working with a particular tool, mainly a calculator, and then IBM showed up. Now, your company isn't old enough, but for the larger enterprises, when IBM shows up, they're trying to take over how you do things. So IBM shows up, and they claim that they can do their jobs much faster. Okay? Now, change is hard. So what happens when someone introduces a new tool or something different? The first thing people do is push back. Why do we need this thing? What's wrong with the old thing? I don't have time to learn the new thing. So we see the pushback. Or some people try to make the new thing work the old way. So for her, the IBM, anyone know how to program an IBM mainframe back in those days? Well, Fortran, actually, in this world. So she taught herself Fortran. How many people know Fortran here? You know Fortran? He's like, it's coming back. It's not. It's not coming back. So she goes and teaches herself Fortran. She learns how to program the IBM mainframe. Any 10x engineers here? Anyone ever seen a 10x engineer? A 10x engineer, so in the Valley, there's a belief that there are some engineers that are 10 times better than other engineers. Anyone believe that? Here's what it looks like. So the best engineers we see can go learn the new thing and teach everyone else. And that's where the scale comes from. It's usually not by working by yourself. If you're a 10x engineer hiding in the corner and you're doing all the working, the smartest person at the company, more than likely you're just really good engineer. You can't scale what you do. So you're not a 10x engineer in my mind. My mind is someone who can take those complex concepts and train everyone else how to do it. Then you leave a lasting impact. Most engineers never get to that level because they don't understand that concept. If you can make the team better than you are, then you've done it. And that's hard to grasp with if you're what we call engineers that have the hero complex. You want to be the go-to person. How many people here are the go-to person? Raise your hand. Are you the go-to person? You have hero complex? Do people know what hero complex is? I've had hero complex. It feels good. Something breaks us like, call Kelsey. You're like, yeah. And you seem to know the answer all the time. And then someone told me that I had a hero complex. They're like, you're kind of part of the problem. If we always have to call you to get it fixed, then you're not doing a good job teaching anyone else how to do what you do. That's a problem. And this is where most solutions fail. And usually when that person leaves or quits, they throw away everything that person's done. It's like, I don't know why we did it this way. Have no context. Let's just do it over. And a new hero shows up. So one thing we're trying to do in the Kubernetes world is making sure that when you introduce this technology to your company, you don't do it with the hero complex. And some people do it. You can identify them. Let's put everything in Kubernetes. They're putting the cape on. They just start doing things the Kubernetes way for no reason. And then when it breaks, they're the only person that can fix it. There's a much better and pragmatic way to introduce Kubernetes into an environment. So we're going to walk through that a little bit. I'm assuming people here know what containers are. Raise your hand if you know what containers are. Okay. Are they exciting?
Not anymore.
No.
No, they are exciting, but in that stage,
So
they are over the excitement.
most people that have been in tech long enough knows that there's always this hype cycle. Containers, go to conference, you have the t-shirt. There are some people that have Docker tattoos. I told them 3 years ago, I'm like, it's not going to be cool one day. You have to explain to people why the hell you have a well on your arm. Doesn't make any sense. So we know that they're just hype cycles because usually something we don't understand, we get really excited about. Then we understand it, and then we understand how broken it is, and then we don't talk about it anymore. All of these things will go through that phase. So when companies tell me that they are looking for their Kubernetes strategy, the first thing I ask them, what is your Linux strategy? And they look at me as like, why would you have a Linux strategy? It's common sense. You can run binaries on Linux, it does what it does, and you move on. Kubernetes, for some people, is already that. It's very common, it's very well understood because it just sits on top of Linux, and it's a different way of deploying things there. And there's some extension points that we'll get into in the Q&A. In this world, this is the vision for Kubernetes, and it's very important to understand. Kubernetes was designed in the cloud. We were assuming people would create lots of relatively small clusters, ranging from 3 nodes to 5,000 nodes, but not 100 nodes. By design, you have to make sure you have that context. By design, it was meant to map to the failure domains, AKA zones or regions. So these give you a normalized compute API, and I'm going to show you that compute API in 1 second. Now, as a developer, honestly, how many developers are here? How many of you care about zones and regions? If you work in ops, no one cares about zones or regions, deployment tools at all. The ideal workflow is I check in some code, it's running somewhere. If it's broken, I have tools to debug it. I used to spend a lot of times in ops. And ops people believe that this layer is actually really, really exciting and really, really important. And there's a huge disconnect between developers and operations. So I'm going to hopefully help you avoid that mistake. So we're going to take the hidden figures analogy and we're going to move it forward some. Here's some code. We're going to look at Fortran now. So imagine that you hire this specialist. This is Dorothy Vaughan, one of the best mathematicians there. And she comes to work at your company. For some reason, you guys are getting into the space business. You're going to do space analytics, whatever. And she starts day 1. And she's going to take in the data from all the things that are in space, aircraft, satellites, and she just wants to calculate momentum on them, okay? So this is a mathematician, and when she shows up, she wants to write Fortran because that's the language she knows, and there's actually a lot of nice libraries still in Fortran. So she shows up. All right, so she has a couple of data points that she wants to feed into her program, and there's going to be billions of these, but this is her sample data set, okay? And she wants to calculate the velocity of these 2 data points. And for her, her favorite language is Fortran, okay? So she wants to write a function that looks like this. So for those, does anybody read this Fortran code? Anyone know what's happening here? Heard you all are really, really smart, so my expectations are high. Someone walk me through this 40-year-old programming language. What is it doing?
Calculating mass velocity and momentum.
This is a good answer, because it says it right here. It's calculating momentum based on mass and velocity as inputs. So what's happening here is Fortran is actually really powerful, by the way. I can read from standard in and format the variables from CSV, comma separated. Here I'm just going to read from standard in. These are the symbols in old school Unix. And then the nice thing is, built into Fortran, it can actually parse CSV without any other libraries. And it's going to assign the 2 fields into these 2 variables. Then I'm going to call this function that's being defined down here in the subroutine. And I'm going to pass in mass and velocity, do the calculation, right? Mass times velocity equals momentum, and return it in this field. So I'm just going to call calculate. And I'm going to write back to standard out 3 fields instead of 2, right? Now, most companies say that they're doing something super special, like the apps that they're writing. If you're doing something similar. Data comes into your application. You do something, data comes out of your application. Is that close? Pretty much. Every company in the world is doing this in some different way. And they believe it's super, super special or something. So computing's been the same for roughly 40 years. Data in, do something, data out. So this is Fortran. Can we run Fortran in Kubernetes? This is actually a really easy one. Can you run Fortran inside of a container in Kubernetes?
Yeah.
Why can you?
Because it's all the things you need and running.
Yeah, Fortran is just making system calls. She's going to call the same system calls available to any other program. So it doesn't have nothing to do with cloud native, has nothing to do with modern applications, has nothing to do with microservices, has nothing to do with monoliths. However you choose to architect your app, more than likely if it's making system calls on Linux, we're going to be able to put it in this container. Great, we've learned that from the Docker world. So this mathematician shows up and this is what she wants to do. So this is, I know what you're thinking. This is a perfect time to teach your DevOps, Kubernetes, Docker, Cloud, VPC, and do all of this DevOps work. Does that even make sense? You have one of the world's best mathematicians, and you're going to give her a kubectl. No one wants to work at that level. So the end game that we're trying to do is make it when they check in this bit of code, they get the compute resources they need. That's the end game. It always has been. But instead, we stop fairly short. So what do we do instead? We say, hey, we need a container. How do you build a container? Anyone have a Fortran compiler on their machine? So here's a Docker file. And the goal here is, if you understand how Docker works, you set up a build layer, you do your build, you get the binary, you copy it to another layer. This is how I make small containers. This small container thing is pretty important in the Kubernetes world because the scheduler is going to be scheduling these things to nodes that may or may not have the container, so you want to make these as small as possible. So these days, what we've done is we pushed this to the developer. So developers are expected to write Docker files. How many developers here write Docker files today? Not many of them. What are the other developers doing? Asking you to write Docker files for them?
It's being done automatically.
So you generate the Docker files for people. So there's a base set of templates. All right, so this is being done for you. Those that didn't know this is happening, you should tell you thank you to your infrastructure and DevOps teams. All right, so you have this Docker file, and you're going to produce this container image. What are you currently using now to manage containers?
Something we built inside.
You built your own thing.
Before Kubernetes was.
You should be happy about this. You're not happy?
About what?
Building your own thing.
I used to, not anymore.
This is a common thing that happens. You get really excited, then you get bored of it, then you want to replace it. Who invented it? Do they still work here? It's you. This is going to be fun. The next thing we expect people to do is write all of this YAML files. Oh my God, it's so much YAML. We expect all the people that want to deploy to Kubernetes to do this next. Now, there are some benefits to this particular thing. If you go and talk to any other company using Kubernetes, they're going to tell you the same process. You describe your app deployments in some YAML file where there's all the specifications of the things you need. I want a deployment type. I can build this particular container in a way. Sorry, this is harder with one hand. So here's my container image. And then you can do things like what CPU, what memory I need, any environment variables, any secrets, any files. And then you can explain things like your load balancer. And this is that Kubernetes API model. This is the most important aspect of Kubernetes. Everything aside, implementation details aside, this has been the most important thing, and we've seen this go in other directions internally at Google where we're using the Kubernetes API at other places. But ideally here we have a service object for service discovery. We can define a certificate so that the system creates the SSL certificate for us. And then we have our ingress controller. You also notice something here that only in a few cases are we cloud provider specific. So these annotations tell GKE, in particular on Google Cloud, how to actually manage the certificate creation and then assign it to the load balancer that will be created afterwards. But basically, this is a declarative config. Most systems are not built this way. Most systems have some imperative language, or maybe there's a lot of side effects that happen. Kubernetes work really hard to allow you to define this. Ideally, your operations team is building these for you. Maybe not you as a developer directly. How do we apply this? kubectl apply. So once you build a container image, we run this one command, even though it has all of those resources in there. This is the process for most companies. You call apply. If you have five clusters, like in this scenario, some people say multi-cloud, multi-region, multi-clusters, federation. Someone's going to give me the answer. I have all of these clusters spread across the globe. If I wanted to deploy that application across all of these clusters, how would I do it? Different contexts. Most people are looking for some magical tool that can manage multiple clusters. I'm going to show it to you. You ready? People will pay a lot of money for this one. Oh, when I show you, it's going to be crazy. Do you understand what I'm saying? Now, the only thing we have to do different here is there's a such thing as a context, right? So ideally, each of those clusters can have a context. Right now, all of my clusters are named after a particular region, or you named it after someone in the zone. So if I say kubectl, so Kubernetes has an idea of a context. So all the credentials needed to log into all of those API servers, you can give them names. So ideally, you write a for loop. Most people are wasting a bunch of time trying to build some custom magical cluster thing. Ideally, if you articulate your workload as a deployment.yaml with all the resources that it needs, you can decide that your app needs to run in, let's say, London and Los Angeles, then it becomes a for loop over both of those contexts. Don't overthink it. Most people are building way too many complex tools to do something which is equivalent of a for loop. Grab the clusters you care about and run the comply either using the command line tool or the API to send the particular thing you want. Once that's done, you end up with your container as a pod or a workload, and we'll get into the details in the Q&A and have some opinions about how to manage some of these deployments. So now this deployment is running. So from that one YAML file, we create a deployment object. We'll talk about some of the other features in the Q&A, and then we'll talk about things like services and ingress. So depending on the cloud provider that you're using, GCP, Amazon, or Azure, those YAML files know how to create the cloud native resources. So different APIs need to be called. And then you end up with this particular load balancer. And it has the SSL certificate generated. It keeps annotations to keep track of all these deployment objects. At the end of the day, as a developer, hopefully you're getting a URL back from your team. Okay? I think there's going to be a future where we simplify this whole Kubernetes thing, but if it comes up in the Q&A, I'll show you. And at this point, we're pretty much done. So the way this application works is it needs data into it, and data coming out of it. That Fortran I have wrapped in some, in kind of a bootstrapping API that knows how to read data from PubSub based on the HTTP event, give the data to Fortran, and then capture the data out and put it in another bucket. So if this is all working correctly, once I do that deployment, I have this workload running. Let me make sure that this app actually works. All righty, let's see. So I'm going to build this Fortran app. I'm just going to compile it locally, so I'm going to show you how it works. Bin, build, Fortran. All right, Fortran compiles fast, apparently. So we have this Fortran binary, okay? We need data in. So here's my data that I want. So we'll do cat input. We'll pipe it to momentum. And ideally, that should be it. And we see that it does all the calculations to spit the data out, right? So I'm testing this locally. I have a bootstrap thing that can actually read the data from Google Cloud Storage, call this function as input to standard in, and take the standard out, right? So fairly simple. Works on their laptop. The developer checks the code in. You build a container for them. You generate the deployment object. You give them a URL that they can hit. In this case, I'm using PubSub to look at an event. So if I upload a file here, we'll take that same input file here, We'll make sure we have no output first. I don't want to be cheating. All right, so we'll take that input from my laptop. We'll grab it in here. We'll hit open, and we'll upload this. And then ideally what we should have is that event shows up, and it's on the other side, and ideally it's working. Let's click on this. All right, and that's the same output. Sorry, this one hand thing is kind of weird. All right, so that's the same output that I had on my laptop. Ideally, Kubernetes gets hidden in this particular flow, and you won't actually see it being used at all. So ideally, developers should be checking in code. And on the infrastructure side, ideally, you're creating these Kubernetes configs and Docker containers for them. So this is a high level of the Kubernetes flow, these objects, the way we think about clusters. But I'm hoping that we have some good questions in the Q&A so we can go into some of the detail. When Kubernetes is a good fit, when it's not a good fit, probably more importantly, and then how people are actually using this thing in production. Maybe we start with that. Do you want to jump in the Q&A?
When is Kubernetes not a good option?
Woo, I love it. What was Kubernetes designed for in the beginning? We spent a bunch of time designing. So Kubernetes, the question is, when is Kubernetes not a good option? When Kubernetes was designed, it was designed for stateless applications. And most people will say stateless is easy, right? Everyone says, oh, stateless is easy. Then I asked them, do they have metrics and logging? Are all their apps super secure? And the answer is no. So even for the stateless stuff, most people have not completed the mission of, when I check in code, it flows nicely all the way through production, pretty secure. We have all the insights and debuggability of that app. Most people stop short of that piece. But Kubernetes was optimized to let you focus on those missing pieces, and we would handle the deployment of those applications, scheduling the resources, running batch jobs, and so forth, assuming that storage was somewhere else, very similar to how Borg runs internally. So Kubernetes comes from this idea of Borg. We were just talking about the Borg white paper in another session. And this idea internally, Google has done a great job of separating state away from the applications. People use things like Spanner, cloud storage equivalents internally, but data is somewhere over there, not intermixed into the cluster. Most enterprises intermix the data and the compute substrate to the point where they can get themselves in trouble. For example, anyone remember the LAMP stack? PHP, MySQL, Apache? And when we used to do that back in the day, we had one machine. You put the database on the machine, put the load balance on the machine, and you put your kind of middleware on that machine. And then if it got overloaded, what's the first piece that you move to another machine?
Database.
Right, so for 20 years, we knew that we put the database somewhere else. So then the app calls the database, and then you separate your storage from the compute, and you can scale them independently. People look at Kubernetes and say, you know what, let's put it all back together. So when you put the database back together with Kubernetes, there's a couple of issues here. Databases have state. Can you use Kubernetes to mount a volume into a container? This is a super easy problem. Deploy MySQL on this machine, mount a database volume, inject it into the container, and it works pretty much like a VM. There's one problem though. Kubernetes doesn't have things like static IP addresses. So if I ever restart the container, it's going to get a different IP. If you get a different IP, that means you have to either configure the clients differently, maybe using service discovery or DNS, but then you may have to tell your replica slave that you've changed. Or you may end up on a different machine. To solve this particular problem, there's a product called Vitess. Anyone ever heard of Vitess? This is the YouTube team. Internally, they have to run on a very similar system to Kubernetes called Borg internally. And for them, they spent 2 years, the YouTube team, a bunch of engineering hours. And they're like, Kelsey, you're wrong about running databases on Kubernetes. I am? They're like, of course you can do it. You have to use Vitess though to help you. I said, okay, let me check it out. So I went to GitHub, and the implementation just for MySQL, this thing has about as much code as Kubernetes itself. So the things that you need to do on top of Kubernetes to run something like MySQL in a way that's really great for Kubernetes, you need a whole nother project and control plane to deal with the issues of scaling, sharding, dealing with the data, backups, and all of these things. Just using Kubernetes is not going to turn MySQL into RDS or Cloud SQL. There's a lot more that goes into it. So this is the first thing that I think most people make a mistake on. Now, if you do want to build a database as a service product, maybe Kubernetes can help you with the deployment aspects, but it's not going to be managing data because it doesn't really have a lot of those concepts built in. Now, people are working on this. So this is where me and the majority of the Kubernetes community split. Some people want to have snapshot APIs inside of Kubernetes, backup APIs inside of Kubernetes. I don't know if this is going to end up well. If you're going to end up in that road, I would probably say put your database nodes on a different set of machines inside of the cluster. So in Kubernetes, you can have different node pools, or in some cases, some of our larger customers have dedicated database clusters. In this cluster, you run Kafka. In this cluster, you run the larger databases, but you leave everything else stateless. Why? So when you're doing upgrades, I should be able to blow away these clusters and bring back most of the apps without being concerned too much about those data volumes. So that's like the #1 area where I don't know if I would use personally Kubernetes to try to run the database if you have no experience running databases in an ephemeral environment. VMs are not ephemeral enough. Most people do not delete the VMs all the time and move things around and change the IP address. So most people don't have the experience, I think, to be running in Kubernetes this way. Are you running databases in Kubernetes? Not yet. Running in a container is fine. It's not even close to the same. You're literally putting the container binaries in a tarball and you're running them on a Linux machine. Fairly straightforward, fairly easy. To me, this is no different than doing yum install MySQL. Now you're doing Docker install MySQL. Instead of using systemd, you're using Docker. This is straightforward to me. Same thing, different way. Kubernetes wants to own the deployment. Kubernetes will evict the process if there's not enough resources. And it's hard to control it and tell it not to. So if you wake up and the database that everyone relies on is now evicted from the machine and getting rescheduled somewhere else, you're going to have a bad time. So then you're going to spend a bunch of time telling Kubernetes, don't ever, under any circumstance, evict this process. Always leave it here. Depending on how big your storage is, network attached storage may be too slow, too much latency. So you're going to start to reverse engineer all these things to back to the point where you should have probably just put it on the VM to begin with. So using Kubernetes may give you a consistent API, but it's not necessarily going to give you all the data management things that you need. So you got to be careful there. Okay? Any more questions?
So you started by saying that developers don't need to care about Kubernetes, but then you show the YAML file, and now they do need to care about Kubernetes.
If you expose it to them.
Right. So that's my question. So what's the right interface to expose to? What's the right platform to expose to your developers? Is it the YAML? Is it Spinnaker? Is it something else? What do you see other companies do?
So the most successful companies have a concept called, company name.yaml. So like AppsFlyer.yaml. And this would be the smallest bit of information that I need from the developer for them to articulate their needs, right? So if I was using something like App Engine, Cloud Run, or Lambda, it's going to be a very small declaration to deploy that particular thing, right? There's limitations in those platforms. So why are people so excited about Kubernetes? It lets you customize the platform however you see fit. So if you're on the platform team, of course you want to make a custom platform for the company. But for the developer population, it would be nice for them to give you a very small subset of information saying, this app needs to run in multiple zones. Maybe there's data privacy issues where it has to run in a particular region. That could be a field. Maybe you can auto-detect a particular language and compile a container for them. But the goal is to really shrink down the amount of data that the developer needs to give you. And at that point, they're just checking in their application and the metadata. And of course, your platform can read that on check-in and do all of the steps and then handle the promotion process. That would be the dream platform. Then it has nothing to do with Kubernetes. It has nothing to do with the cloud provider, and it has nothing to do with whatever else you're currently doing. So my guess is most developers would love a system that makes them think about the least amount of things. Change it all the time. How many developers have went through platform changes? Only you? No one here has ever went through a platform change? Wow, you're lucky.
Shy.
What's that?
They are shy.
They're shy. Oh, wow. Only you two do everything?
There are a couple of developers that do.
Okay. Well, so for the most part, I want to make sure that developers have time to focus on building the application and not wiring up the platform. Would someone like a different platform than that? Is there a developer that prefers to have access to everything? You would like have access. Why do you want access to everything?
I like to understand how things are walking underneath the surface.
Everything.
Yeah.
He's the CDO, right?
There is a case.
You get as a developer, it's okay.
So I hear this a lot. Developers want to know how everything works under the covers. So I ask developers, what programming languages do people write in here?
Closure,
Go.
Closure, for example. All right, so, okay, JVM, you run on top of the JVM. So let's say you import some libraries. And then you ever do a build and you see a bunch of other libraries get installed? You're like, whoa, we just downloaded the whole internet. Then I'm going to ask you a question. Do you go and look at all the source code for all the dependencies? Be honest. Do you look at all the source code for dependencies? No. So if I had a developer and I said, if you want to understand how something works, I want you to understand how all of those dependencies contribute, because most of the security stuff we see is from those dependencies no one looks at. So if I have a developer, there's nothing wrong with learning how the system works. But if I see you touching the kernel and touching Kubernetes, and I ask you, have you seen the dependency code? You're like, no, I'm focusing here. I'm saying, I have a lot of platform people. They're focusing here. I need you to look at the code, even the dependencies, because half of my vulnerabilities is like, I don't know. It's something we imported that imported something that imported something. Most developers don't know how the code works. This is where that separation of concerns is super critical. Like, your customers don't know how your system works. My guess is they send some data, they click around, they smile, they pay you money. It's a good experience. I like that separation even internally. If you're the platform team, if I want to know, don't say I can't look. I do like the freedom to say I want to learn and understand. You should definitely make that available. But I don't want to have to learn to understand. Like some people, if you don't learn Kubernetes, you can't do deployments at some companies. Well, I got to spend my time somewhere. So I think it's probably critical to give people the ability to focus in their area of concern, so that way we can kind of work together.
So to follow up on that, how do you suggest balancing? So for me, the idea of having control or using Kubernetes or whatever directly is not about knowing how everything works. It's more about preventing bottlenecks or unnecessary bottlenecks. So for example, if I'm a developer and I need to provision or not provision, create a bucket in S3, and usually the operations team kind of has a declaration for me for that, but for specifically the buckets are not stored. And all that needs to be done is kind of add like a small section to a YAML file, and now I'm stuck, right? So now I need my operations team to provide me that DSL specifically for me to provision 3 buckets.
So this is a good question. So here's the question. So, a lot of people, and I've been in this situation on both sides, it's really hard to ask the platform team to keep up with everything you want to do, right? Like if you see a new idea, you just want to use it, you may not have time to roll it back officially in the platform and use it through that company.yaml process. So what do you do instead? So I think one good balancing workflow, and we kind of see this internally at Google as well, okay, you have to break off the rails, and you have to do stuff out of band. At some point, someone's going to have to know how you made those changes so we can all be responsible. Because even if you leave, we all need to know how it works at some point. So a lot of times you'll see developers do a rotation onto the platform team. So we have different levels of platform. There's like Borg. There's also the libraries like Stubby or gRPC. Each of these teams tries to encapsulate the patterns that are useful for everyone else. So maybe you do have a one-off that only needs to be done once and never again. Then great, do the one-off. Here's the tools, empower yourself. But when it becomes a thing where everyone is creating buckets in a certain way, then maybe we have to wrap it back into the platform.
Yeah, that's for sure, but I mean, you talked before about like not exposing those capabilities to developers. So
how often is this happening?
I mean, to enable this one-off developer go and do your thing, you need them to be able to access the Kubernetes.
So what we call this is break glass. You need the ability to break the glass in an emergency. Ideally, this is not happening.
Like a production emergency for my development alone.
Yeah, so think about it. If you are always creating buckets, right? Like some people used to create volumes on VMs. Kubernetes had no volume abstraction when it first came out. But people are manually creating volumes and attaching it to containers manually. So Kubernetes added it to the API, exposed it into YAML. There's always going to be a trailing set of things that you want to do. What you have to decide is that should that eventually live in the platform or not? If it should, of course, break glass. But at some point, your team can extend the platform itself, right? If you're going to make it better for everybody else, that may be one scenario. Or internally, Google, most of our internal products have product managers. You would open a ticket with the product managers like, hey, this platform needs to be able to manage volumes. Here's our use case. Until then, we're going to do it ourselves using this manual process. And hopefully the next release of the platform supports your use case and you don't have to do it that way.
But doing this myself, what does it mean? Does this mean writing YAML Kubernetes files?
There may not be any YAML Kubernetes files. You may literally have to go to AWS command line tool or G-Cloud tool and create the bucket, right? So
whatever it takes manually, and then
yeah, if it's an emergency, it's like this is what we call break glass. But ideally, if you have a platform mindset, in 5 years' time, hopefully you've seen enough patterns where 90% of the scenarios are just baked into the platform because that's what people need, right? But until then, every time you find a use case, if you want to solve that problem for everybody at the company, you say, hey, this is a use case we need. It needs to be in the platform. The Kubernetes community is adding more and more of these things over time. The thing you just mentioned, in Kubernetes, we're adding this thing called, and at least for GCP, we want every GCP resource, buckets, load balancers, IAM rules, you name it, to have a Kubernetes API equivalent. So ideally, you can push it to the cluster, and then we will call the APIs using a specific service account instead of people using the command line tool. So in your use case, you would be able to add that particular thing either to whatever the infrastructure repository is, maybe use kubectl as break glass to put that config in place. The platform team will see this pattern. Wow, you're using this resource a lot. Should we encapsulate it? Right? So that's the tail end, but you're never going to get it right day one, but it's the platform team mindset of what should make it back. But ideally, the rest of the people that don't have that problem, they should just be able to use the normal flow, right?
So once I tried to start playing with Kubernetes, and to be honest, it scared me a little bit because I found it very sophisticated piece of tool, and I found myself prefer to use building blocks rather than one piece of tool that tries to solve everything. So I found myself prefer to use the Mesos management, for example, and also for discovery, for say managing secrets. So
okay. So I come from this world, and I remember before Kubernetes showed up, this is what everyone was doing. You have Docker for container management. Some people were using Mesos, building Mesos frameworks, bringing in service discovery, bringing in volume management. For you, it's like, oh, this is so simple. Everyone else is like, oh my God, that sounds like a lot of tools made by different vendors with no interop, no common API. Wow, that's a lot of bash script. You want me to run that from my computer? Then you built this thing. You just have this thing. And the rest of the world evolves, and you still got this thing. And everyone's like, wow, Kubernetes can do all these new things. Can your thing do that? You're like, there's only 3 people working on it. We'll never be able to catch up to that. So you mentioned Mesos. Mesosphere. You know that company. You know Mesosphere, right? Let's see if we can find. Oh, look, they changed their name. Oh my God. Mesosphere is now DQIQ. The hell is going on? Mesosphere changed their name? What's going on? Let's look at the solutions. Oh, what's this K-Sphere thing? Kubernetes? Mesosphere is talking about Kubernetes. The company that invented Mesos is talking about Kubernetes, and then they changed their name. I'm interested. Forget my opinion. Why would they do this? What was that?
they want to stay in business. Kubernetes become popular.
They want to stay in business. Popularity. So I remember the days when Sun Solaris was the best Unix operating system. Remember? Oh, it's superior. NFS, network everything. It was the best. And then Linux, everyone was laughing. Oh, look at the Linux thing. It's terrible. Solaris is more scalable. Everyone's using Solaris for big systems. It's the best. Solaris is not even a thing anymore. It's gone. Linux is what everyone is using. You still have a Solaris box at home.
10 years ago, everybody was talking about OpenStack.
No, I was not talking about OpenStack 10 years ago. I knew that was not going to work. I remember clearly talking to the guy, like, that's not going to work. Kubernetes is different though, because I actually seen it work for lots of people in production. That's my test. There are people making noise and there's people using it in production. Kubernetes is one of the things I saw used in production within 2 years of its debut because it was focused. And it's growing more capabilities. And when you start to think about Mesos is the reason why, and I remember I interviewed there before I went to CoreOS. And I looked at their Mesos strategy, I was like, this doesn't have the momentum. The problem with that whole two-part scheduler thing was a great white paper. It made sense logically. Your resource offers, Hadoop can take some resources, Aurora can take some resources, and if you're lucky, they do the right thing with the resources. Then over time, what do we see people doing? Hadoop takes all the resources. Aurora's like, I can't see anything, right? And then you have to try to give the resources back. And we wrote a whole white paper about that with the Omega paper of why that model would not scale for usability reasons. If the cluster manager cannot see all the resources, then it can't make some intelligent decisions, right? So in the Kubernetes model, since there's only one unified resource model, everything is a container in a pod. It can see all resources. That means it can coordinate between batch jobs, long-running jobs. People have ported Spark to Kubernetes and taught it how to create pods. Everything is the same, so no matter what the front end, Spark or whatever tool you're using, Cloud Run, Knative, at the bottom, it's always a pod and a container. Then you can build emission hooks, like emission controls to say, I have a security policy that says no one can use environment variables. It doesn't matter what tool people put into the system, you're gonna always end up with the same spec and API across the board. Then we were able to scale within 5 years, way past mass adoption of Mesos because of the usability. When the usability came, service discovery is baked in, has some opinions. You can still use console inside of Kubernetes. Matter of fact, who makes console? All right, let's go there. Because we got to stick to facts, right? So you go to console. Do you know the biggest new features for console? What are the biggest new features for console? Anyone know? Huh? You notice one thing that they don't even mention their own cluster management tool here. This, and I know the people at HashiCorp, Mitchell and friends, this has become so much part of their marketing. Number one is console is also pivoting because service discovery is no longer a big deal because it's baked into so many platforms by default these days. There's not a lot of value for that project to stand on only. You can still use it if you wanted to, has some good use cases. But the nice thing about console now, it can just scrape the Kubernetes API directly. It's built into the docs. You can say, hey console, here's how you talk to the Kubernetes API and grab services from it automatically and let Kubernetes do the health checks. We made the API so extensible and so easy to integrate with that companies like HashiCorp can leverage the API and extend the system themselves. I don't know how their docs are laid out, but more than likely you'll see a whole doc section just for Kubernetes because it's a consistent API. They don't have to worry about how any other system above it is behaving. The service discovery is consistent across all tools. The runtime is consistent across all tools. So even though the modular effect seems very appealing, the system that you're going to assemble, you're gonna have to try to keep track with all these independent APIs and stitch them together yourself. Whereas in the Kubernetes world, the whole thing is API driven. So when I learned Kubernetes earlier when I was a contributor, Kubernetes is only really two things. There's a data model that's stored in etcd, and we don't use etcd for service discovery. Kubernetes implements its own service discovery, not etcd. And then we have this data model that goes to the API server. Every other component is modular. The scheduler is pluggable. You can actually turn off the scheduler and use your own scheduler. This is one of the first projects that Mesos worked on. If you want to use service discovery with etcd, you can install etcd yourself and tell your apps to get etcd or get DNS from there or whatever service discovery protocol. So it's actually super modular. What it does have, though, is everything out of the box by default. We try to take everything we've learned and give it a consistent API, and when you don't want to use it, you can plug in. So I've used console before joining Google with Kubernetes. And by using the Kubernetes or console DNS, in Kubernetes, you can actually delegate DNS to console. So all your apps can continue to still use console, no changes, but now console runs in a slightly easier mode by talking to the Kubernetes API service, one single model. So you don't actually have to give up anything. you can actually still use as many of those modular components that you want. We just have clean API services for you to integrate. Any other questions?
Is cloud agnostic or multi-cloud a thing for a lot of companies? And if yes, then when should we start thinking about it? And lastly, is Kubernetes, in your opinion, a key enabler to that?
So the question is, multi-cloud, is that like a real thing? How many people believe in multi-cloud? All right, so the multi-cloud promise is that you can leverage all the cloud providers in the exact same way. I've never seen this done unless you use the lowest common denominator, VMs. If you stick with VMs and do everything yourself, you have a chance. And there's other one gotcha, where there's mainly two, maybe three. Storage, networking, and IAM. Those are the three that will always be different, or you're gonna have to figure out how to sync data and pay the cost. You can't get around those three challenges. This is how it's going to work. The one thing that Kubernetes helps with, I think, are companies doing it. Yes. I think Uber gave a great presentation at KubeCon recently that they need to have compute everywhere, and sometimes they just pick cloud providers based on the region. They do some of the hard work underneath Kubernetes. Sometimes you want to integrate using a different networking stack on one provider over the other. But at the end of the day, what you expose to the higher tier systems is the Kubernetes API. So I think the Kubernetes API is the thing that you can use to normalize the compute part of the cloud. We're addressing IAM as well. So in Kubernetes and GKE, for example, the service account that you give your containers, we map to IAM. And now you can have a reference to say, this container gets this service account and it maps to this service account by the same name. And you can just do permissions in Google Cloud and extends to the container. And we built this as like a metadata service that gives every pod the same metadata API that the VMs get. You can imagine us extending this to Amazon as well. So that way you don't have to think about individual IAM setups. You can just use your Kubernetes credentials and then make Kubernetes a trusted provider of authentication. You can do this in Amazon today with Kubernetes. You can actually have those service account tokens be respected by and trusted by Amazon to connect to S3, for example. Do I believe it's the best hope for people running VMs across multiple cloud providers? Yes, containers on those VMs. But if you're using IaaS, then yes, Kubernetes is probably the best choice versus starting from scratch. So you can start from scratch, take a bunch of VMs, install Docker, install console, install all of these things until you get something that looks very similar to Kubernetes. But then you're gonna have to maintain it yourself, and my guess is you will not have time to build a complete API set. I think there's thousands of Kubernetes developers, including IBM, Red Hat, Google, and so forth, even Mesosphere. My guess is this might be the easiest place to start. Do the hard work underneath. GKE, click the button. More than likely, it's gonna be very similar in terms of API compatibility with the other cloud providers. So yeah, I see it already playing a major role for most companies. Not that it's gonna make everything else you do super simple, but at least for the compute substrate, it's gonna be consistent. We'll take one more, then I have to run. All right, two real quick. Yeah, so I remember when the team started working on that 3 years ago. So the question is, Spark now in 2.4 has been taught how to run on Kubernetes natively. So in the Mesos world, you create a framework, there's a job, Spark understands it, Spark manages everything. It took us maybe 2.5 years to teach Spark how to create Kubernetes jobs and let Kubernetes manage the resources. There's a different model where you can run Spark with pre-allocated resources, a bunch of workers, and then you tell Spark about it, and it does it the old way. But they've been teaching Spark how to do dynamic jobs, meaning create the jobs, define the workload container, and then it will dynamically give that to the scheduler. Kubernetes will do the placement, and the job will run, and then Spark will have a way to feedback. They did it correctly. That's the thing that's nice about it. They took 2.5 years. Couple of the people were from Mesosphere. When they came to Google, they wanted to learn Kubernetes to do it the right way. So now we actually have delivered on one of the original Mesos promises. Different schedulers, being able to use unified compute in the shared way, and by doing that, we've taught Spark how to talk to Kubernetes the correct way, and using the pod API versus pre-compiling all their own compute and runtime. So everything is container-based now. I think they did it the right way, and they're looking for long-term support, and now that Mesosphere is also on board. My guess is that this is gonna be a sustainable project. So I like it. We'll take this last one. All right, so the question is the statement. The statement is containers don't contain anything, and you have to rely on something a little bit more robust if you really want isolation, right? And this is a very old discussion. Shared kernel, any vulnerability in the kernel, if you have two apps running on the same VM or physical machine, if they have access in any way to the same kernel, more than likely, you're gonna have a kernel exploit and you're gonna get in trouble. The kernel does not contain anything. One exploit at the kernel level, who cares about the kernel features you're using, including SE Linux? All of those are vulnerable to any kernel exploit. So you have to figure out a way to remove the shared kernel. VMs are one way. Hypervisor, separate kernel. VM tries to give you another kernel running on top, and then you have a layer in between you and the shared kernel. So some people feel comfortable with hypervisors as a security boundary. We don't necessarily think that's enough either. It's just that most people believed for a long time that the stuff that Intel was doing was super secure. With Spectre, most people don't believe that anymore. So you're in a similar boat. Any exploits there. Now in the Intel CPU, so all of this is kind of mute. But the shared kernel is your number one concern. That's the attack vector that you're worried about. So what people are doing now is, how do we partition the shared kernel? You can do it with VMs. So if I take a host, a Kubernetes host, and I launch every VM or every container inside of its own KVM instance, many ways you still have a shared kernel underneath, but you have another layer above where everyone is making system calls to their kernel, then going through a hypervisor only for necessary syscalls that need to go that low. So you're reducing the blast radius. Okay, gvisor is another way of doing this. Gvisor runs in user space. It emulates all the syscalls. So you have another layer of indirection that no one's calling most syscalls directly to the kernel. And then the third option is custom runtimes, where you strip away bad syscalls at the runtime level. This is how App Engine worked for years. So App Engine has custom runtimes, strip dangerous things away, gvisor, intercept all syscalls, and partition the kernel from multiple people. That's your only options. It's a trade-off on performance. You're gonna lose overhead each of those steps. So if you have a trusted environment, as I wrap up here, we just announced in beta trusted compute or shielded VMs for Kubernetes. So just like my Chromebook, right? It's trusted from boot all the way through, and it only runs signed software. So one part is trusting the machine that I'm actually running on, and only allowing things that my team has built or we trust to some extent. So we have a trusted compute platform. Maybe I'm okay to take the shared kernel risk in those environments. When I'm not, then you add gvisor. So in Kubernetes and GKE, for example, when you click it, you can enable, I think what we call it, something isolated containers. But basically, you have the ability, when you deploy your work, to say you isolated container, then we run it under gvisor instead of containerd directly. So then you end up with a gvisor thing. And we believe gvisor addresses your concerns because we've been using that on App Engine for a very long time. Right? So I think going forward, yes, people will be making the trade-off. Do you want more isolation or not? You have to decide. And there is a performance penalty you pay. It's not free. So if you put everything inside of VMs on top of VMs, you're going to pay a performance price, especially in some of the I/O departments. So I don't think everyone's going to run around and turn on VMs for everything because it's going to be a challenge in overhead. Cool. All right. Thank you all.